It is not safe to use a three-phase transformer with a single-phase panel board for several reasons. Firstly, the transformer is designed to handle a balanced three-phase load. Connecting a single-phase load to the transformer will result in an imbalanced load, which can damage the transformer's windings. Secondly, as you mentioned, one leg of the transformer will be left open. This will cause circulating currents to flow in the windings of that leg, which can generate heat and harmonics. Thirdly, the circulating currents in the unused leg can cause the transformer to overheat, which can lead to premature failure. Fourthly, using a three-phase transformer with a single-phase panel board is a violation of the National Electrical Code, NEC, and may void any warranties on the equipment. There can be consequences of using an incorrect transformer. The transformer can overheat and fail, resulting in downtime and costly repairs. The imbalanced load and circulating currents can damage equipment connected to the panel board. Overheating transformers can pose a fire hazard. The correct solution is to replace the transformer with one that is rated for single-phase operation. This will ensure that the load is balanced and that the transformer operates safely. You may also need to replace the panel board with one that is rated for the correct voltage of 120/240 volts. While it may be tempting to try to make do with the incorrect transformer, it is not advisable to do so for the reasons stated above. It is best to correct the mistake as soon as possible to avoid potential problems. A more detailed explanation of why this is not acceptable follows. A three-phase transformer is designed with three sets of windings, each intended to carry an equal portion of the load. When you connect a single-phase panel to a three-phase transformer, you are only using two of these sets of windings. This creates an imbalance in the transformer, as two phases are heavily loaded while the third phase is virtually unused. This imbalance causes several problems. The loaded phases will experience higher current flow than they were designed for, potentially leading to overheating and insulation breakdown. The unused phase will still have voltage induced in its windings due to the magnetic field created by the other two phases. However, since there is no load connected to this phase, the energy has nowhere to go. This can lead to circulating currents within the winding, further contributing to heat generation. The unbalanced load can also cause voltage imbalances in the system, which can negatively impact the performance and lifespan of other electrical equipment connected to the panel board. This can be particularly problematic for motors and other sensitive electronic devices. Transformers are designed to operate within specific voltage and current parameters. Using a three-phase transformer to power a single-phase load can push the transformer outside of these parameters, leading to premature failure. The National Electrical Code, NEC, provides guidelines for the proper installation and use of electrical equipment, including transformers and panel boards. Using a three-phase transformer to power a single-phase load is a violation of these codes, as it creates an unsafe and unreliable installation. The NEC addresses balanced loading and proper transformer application in various sections. While I cannot provide a specific NEC table without knowing the exact details of the installation, some relevant sections include Article 450, which covers transformers in general, and Article 220, which deals with branch circuit, feeder, and service calculations, including load balancing. Local electrical codes may also have specific requirements regarding transformer installations. In addition to the technical and safety concerns, using an incorrect transformer can also void any warranties on the equipment. Manufacturers design and warranty their products based on the assumption that they will be used according to their intended purpose. Connecting a single-phase load to a three-phase transformer is a misuse of the equipment and will likely invalidate the warranty. A much better solution is to replace the existing transformer with a single-phase transformer that is properly sized for the load. This will ensure a balanced load, prevent circulating currents, and maintain compliance with electrical codes and safety standards. When selecting a single-phase transformer, it is important to consider the voltage and current requirements of the panel board. The transformer should be rated for the same voltage as the panel board, which is 120/240 volts in this case, and it should have sufficient capacity to handle the total load connected to the panel board. It is also important to ensure that the transformer is properly installed and grounded according to the manufacturer's instructions and all applicable electrical codes. This will help to prevent electrical shock and fire hazards. If replacing the panel board is also an option, consider using a 3-phase panel board that is rated for 120/208 volts. This would allow you to utilize the full capacity of the existing 3-phase transformer and provide a more balanced and efficient electrical system. However, this would require replacing all of the single-phase loads connected to the existing panel board with 3-phase loads, which may not be practical or cost-effective. In summary, using a 3-phase transformer to power a single-phase panel board is not a safe or reliable practice. It can lead to transformer failure, equipment damage, safety hazards, and code violations. The best solution is to replace the transformer with a single-phase unit that is properly sized for the load. If replacing the panel board is also an option, consider using a 3-phase panel board that is rated for 120/208 volts. This will help to ensure a balanced and efficient electrical system. Always consult with a qualified electrician or electrical engineer to ensure that all electrical work is performed safely and in accordance with all applicable codes and regulations. The issues associated with using a 3-phase transformer to feed a single-phase panel board can be further broken down into several key areas. These areas include transformer loading, voltage imbalances, harmonic distortion, and safety considerations. Firstly, regarding transformer loading, a 3-phase transformer is designed to have its load distributed evenly across all 3 phases. This ensures that each winding carries approximately the same amount of current, minimizing stress and heat buildup. When a single-phase panel board is connected to a 3-phase transformer, the load is concentrated on only 2 of the 3 phases. This results in an unbalanced loading condition where 2 phases are heavily loaded while the 3rd phase remains relatively unloaded. This unbalanced loading can lead to several problems, including overheating of the loaded phases, reduced transformer efficiency, and shortened transformer lifespan. Secondly, voltage imbalances can occur when a 3-phase transformer is subjected to an unbalanced load. The voltage in the heavily loaded phases will tend to drop, while the voltage in the lightly loaded phase may rise. This voltage imbalance can negatively affect the performance of equipment connected to the panel board, particularly motors and other sensitive electronic devices. Voltage imbalances can cause motors to overheat, vibrate excessively, and consume more energy. They can also lead to malfunctions or premature failure of electronic equipment. Thirdly, harmonic distortion is another potential issue when using a 3-phase transformer to feed a single-phase panel board. Harmonic currents are generated by nonlinear loads, such as electronic devices with switching power supplies. These harmonic currents can flow back into the transformer and cause distortion of the voltage waveform. The unbalanced loading condition exacerbates the problem, leading to higher levels of harmonic distortion. Harmonic distortion can cause a variety of problems, including overheating of transformers and conductors, interference with communication systems, and malfunction of electronic equipment. Fourthly, there are safety considerations. Overheating of the transformer due to imbalanced loading can create a fire hazard. Damaged insulation can lead to electrical shock hazards. Voltage imbalances and harmonic distortion can also create safety hazards by causing equipment to malfunction or fail unexpectedly. Therefore, it is important to address these safety concerns by using the correct type of transformer and ensuring that the electrical system is properly designed and installed. The specific NEC articles related to these issues include Article 215, which covers feeders, Article 220, which covers branch circuit, feeder, and service calculations, and Article 450, which covers transformers. These articles provide guidance on how to properly size transformers, balance loads, and mitigate harmonic distortion. In addition to the NEC requirements, it is also important to follow the manufacturer's recommendations for transformer installation and operation. The manufacturer's instructions will provide specific guidance on how to properly connect the transformer, protect it from overloads, and maintain it in good working condition. Here are some additional points to consider. Firstly, the size of the transformer is crucial. A transformer that is too small will be overloaded, leading to overheating and premature failure. A transformer that is too large will be inefficient and may contribute to voltage imbalances. The transformer should be sized to handle the total load connected to the panel board, with some additional capacity for future expansion. Secondly, the impedance of the transformer is also important. The impedance is a measure of the transformer's resistance to the flow of alternating current. A transformer with a high impedance will tend to limit the fault current in the event of a short circuit, protecting downstream equipment. However, a transformer with a high impedance may also contribute to voltage drops under heavy load. Thirdly, the grounding of the transformer is critical for safety. The transformer should be grounded according to the requirements of the NEC, using a properly sized grounding electrode conductor. Proper grounding will help to prevent electrical shock hazards and protect equipment from damage due to ground faults. Fourthly, the overcurrent protection of the transformer is essential. The transformer should be protected by fuses or circuit breakers that are sized to protect the transformer from overloads and short circuits. The overcurrent protection devices should be coordinated with the downstream overcurrent protection devices to ensure that faults are cleared quickly and safely. In conclusion, using a three-phase transformer to feed a single-phase panel board is generally not recommended due to the potential for unbalanced loading, voltage imbalances, harmonic distortion, and safety hazards. The best solution is to use a single-phase transformer that is properly sized for the load. If a three-phase transformer is used, it is important to carefully consider the loading conditions, voltage imbalances, harmonic distortion, and safety implications. The electrical system should be designed and installed in accordance with the requirements of the NEC and the manufacturer's recommendations. Always consult with a qualified electrician or electrical engineer to ensure that all electrical work is performed safely and in accordance with all applicable codes and regulations. Remember to always de-energize electrical equipment before working on it. Follow lockout-tagout procedures to prevent accidental energization. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Be aware of the potential hazards associated with electricity and take precautions to avoid them. Only qualified personnel should perform electrical work. If you are not qualified, do not attempt to work on electrical equipment. Seek the assistance of a qualified electrician.